एवरीबडी इज रेडी और एक और जना आने वाला है. Okay, I think I should start. Okay, so हाँ, कोई और आ रहा है कोमल अभी या should we start actually? I guess.
So we can start.
Okay, fine. Thank you. Okay, so I think okay, 1 minute. मेरे को share करना पड़ेगा ना. I forgot to share. 1 minute. So can you see the desktop? Okay, fine. So आज हम थोड़ा सा finite fields के बारे में और बात करेंगे, especially irreducible polynomials, and I will try to show you how to factor x raised to n minus 1 because it's a very important concept. So let me show it to you. So I think if I, so you know that a field with q number of elements is 0, 1, alpha 2, alpha q minus 2, right? Where q is a prime power. So finite field with q elements. So there are certain properties of finite fields which I would like to mention here. Properties of finite field. मैं थोड़ा शॉर्ट हैंड notes use करता हूँ. Finite, less than infinity means finite. Okay. Suppose beta is an element, it's a non-zero element of GFQ, field with Q number of elements. Okay. Then we can define what is known as order of beta is the smallest positive integer such that beta raised to power m is equal to 1. Okay, that is the definition of order. A polynomial is said to be irreducible polynomial if it cannot be written as product of two lower degree polynomials. Okay, then we say that a polynomial is irreducible polynomial. Next property, if t is the order of beta, okay, so that means beta is for t is equal to 1, t is the smallest such integer, then t divides q minus 1. Okay, why is that? Because you know that if I call gfq as a field with q number of elements as fq, so then fq star, I think you can observe this in the examples that we did last time, that fq star means you look at fq and delete 0 from there, you know, that's notation, sometimes use it. So all non-zero elements forms a multiplicative group. Okay, so multiplicative group means that is the order. So the cardinality of fq star is q minus 1. So the order of fq star is q minus 1. Okay, and since beta is an element of fq, that means basically uh, order of element divides the order of the group. That is a you know, 1 minute. So we know that order of element divides order of the group. Using this definition, we arrive at if t is the order, then t divides q minus 1. G is a group, you know, if G is a group, then this happens. Okay. Now, also in any GFQ, there are one or more elements ऑफ ऑर्डर q माइनस 1. ऐसा हो सकता है कि जो हमारा सेट है GFQ, सो हमको ये मालूम है कि GFQ के एलिमेंट्स का ऑर्डर पूरी फील्ड के ऑर्डर का नॉन जीरो फील्ड के ऑर्डर को डिवाइड करेगा, विच इज q माइनस 1. बट ऐसा भी हो सकता है कि ऑफ कोर्स t could be q minus 1, so that means there are few elements in GFQ जिनका ऑर्डर एग्जैक्टली q minus 1 हो. तो ऐसे एलिमेंट्स को हम बोलते हैं प्रिमिटिव एलिमेंट्स. ओके, ऐसे एलिमेंट्स को हम बोलते हैं प्रिमिटिव एलिमेंट्स जिनका ऑर्डर q minus 1 हो. सो आई थिंक वी कैन लुक एट एन एग्जांपल हियर. फील्ड हमारी इंटीजर मॉडल 5 है, सो एलिमेंट्स आर 0 1 2 and 3 and 4. Okay, so 1 raised to power 1 is 1, so order of 1 is 1. Okay, 2 square, you know, is 4, fine. 2 cube is 8 modulo 5, which is 3. 2 raised to power 4 is 16, so this is 1. So order of 2 is 4. 2 raised to power 1 is 2 actually, right? 2 raised to power 1 is 2. 2 square is 4. 2 cube is 3. 2 raised to power 4 is 1. So 4 is the smallest order for which raised to the power 2 is 1. So order of 2 is 4. Similarly, you can check that order of 3 is 4 and order of 4 is 2. Okay, because 4 raised to power 1 is 4 and 4 square is 16, which is 1, right? So there are two elements, so 2 and 3 are primitive elements here. 2 and 3 are primitive elements. Any question at this point? I hope you understand what is the meaning of primitive element. Okay, so okay, I think another interesting function that we study in number theory is known as Euler quotient function. What is Euler-Torsion function or Euler-Phi function? Sometimes it is also known as Euler-Phi function. Okay. So actually, for an integer n, phi of n is defined as positive integer. I am talking about number of integers between 0 and n minus 1 that are co-prime to n. Okay, so in other words, we know that phi of 3 is what? So numbers are 1, 2, 3. I mean, right? So between 0 and 3, right? So how many numbers are there which are less than 3 and co-prime? There are only 2. Okay. Similarly, we can say that what is the value of phi of 15? You can check that the phi of 15, the value is 8. Okay. What is the value of phi of 10? Phi of 10 is 4. I mean, so you can write it down numbers like say 1, 2, 3, 4, 5, 6, 7, 8, 9, right? So 10 से कम इतने नंबर हुए which are positive और जिनका GCD 10 से 1 है एक्चुअली तो कौन कौन से हैं इसमें 1 हो गया 3 हो गया 7 हो गया और 9 हो गया राइट जिनका GCD 1 है so the numbers are 1 3 7 9 which are co-prime right so इसलिए phi of 10 is equal to 4 in fact we also have phi of 1 is equal to 1 and if p is a prime number then phi of p is equal to p minus 1 okay so phi of p is equal to p minus 1 if p is a prime number now what is the phi of 6 phi of 6 you can also compute it like phi of 2 into phi of 3 phi is a multiplicative function so actually this value will be phi of 2 into phi of 3 2 is a prime 3 is a prime right so this value is 1 into 2 which is 2 okay in fact we have an interesting relationship which says that I would say that there is a theorem that if n is a integer like p1 raised to power e1 p2 raised to power e2 dot 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 pr raised to power er product of prime so pi's are prime numbers then phi of n is nothing but p1 raised to power e1 minus p1 raised to power e1 minus 1 and so on dot 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 pr e raised to power r minus pr e raised to power r minus 1 okay so this is also written as n partial product p divides n 1 minus 1 by p okay so this is a formula so in fact from this formula I can find out the value of phi of 6 as 6 into 1 minus 1 by 2 into 1 minus 1 by 3 which is 2 okay you can check that phi of 63 some of these things now you can verify okay so these are some basic things I can also mention say what will be the phi of 98 phi of 98 will be phi of 2 into 7 square right which is 2 minus 1 I am showing you different ways through which I can compute these values is 42 And by the way, on PeriGP, on the command prompt, if you type ILR5 98, you will get the answer 42. Okay, so this is the Euler torsion function. Why we are doing this Euler torsion function? So it's a very interesting theorem here that I want to mention. The number of elements in GFQ of order T is phi of T. This is a beautiful result, that if I have to count how many elements are there of order T in GFQ, so they are phi of T. Actually, it is given by this function. Okay. For example, I think you can construct the field GF16 with 16 number of elements, which is GF2 raised to power 4. So, and you can use the polynomial pi of x, irreducible polynomial, to construct the field is x raised to power 4 plus x plus 1. So then alpha is square, and alpha raised to power 4 are primitive elements here. Okay. Whereas alpha 3 and alpha raised to power 4 are not primitive elements. So primitive elements means the order of alpha is 15. Order of alpha square is 15. Order of alpha raised to power 4 is 15. Okay. So I can mention here a polynomial having primitive element as its roots. ऐसा polynomial जिसके roots primitive elements हो, right, is called a primitive polynomial. PP, primitive polynomial. Okay, it's called primitive polynomial. So I think in GF16, so this polynomial is primitive polynomial, whereas if you take the polynomial x raised to power 4 plus x cube plus x square plus x plus 1, this is irreducible. Of course, you cannot factor into lower factor than this, but this is not a primitive polynomial. Okay. So is it clear what is the meaning of primitive element of a field, finite field, primitive polynomial, and irreducible polynomial? Okay. So I earlier mentioned to you that FQ star, or GFQ star, field with Q number of elements. The star means I am deleting 0, is a cyclic group cyclic multiplicative group, by the way, group of order Q minus 1 or P raised to power M minus 1, because Q is equal to P raised to power M. Okay. So any question at this point? Any question? Are you there? Praveen, Ashish?
Yes, sir, we are getting.
You are getting everything? By the way, you know about groups, or do I need to cover that also? The groups.
So,
Yes,
so we know a little bit. Can just give us a little brief of that. That will revise our concepts.
Okay. So group is basically a non-empty set together with a binary operation, such that it specifies 4 properties. Number 1 property, that it is closed with respect to the operation, right? So I think I'll just mention here. G is a non-empty set, and say circle is a operation which is binary operation, such that a circle B belongs to G for every A and B in G. अगर G के कोई भी दो एलिमेंट्स लेंगे और ये क्लोज होगा विद रिस्पेक्ट टू दैट, ठीक है ना. सेकेंड प्रॉपर्टी क्या होती है? Associativity property, that A circle B circle C the same thing as A circle B circle C for every A B C in G. It's associativity. Third property, existence of identity element. For every A in G there exists E such that A circle E is equal to A is equal to E circle A. Okay, existence of identity element. Fourth, there exists inverse. So for every A in G there exists A inverse such that A circle A inverse is equal to E is equal to A inverse circle A. Got it? This is the basic definition of a group. Okay. So now your this set FQ star. So basically when we are looking at field, for example, if you take GF4, sorry. So for example, when we look at what happened, I don't know. Yeah. When we look at GF4, so we know that field with four number of elements, it was 0, 1, alpha, alpha square, remember? So if we form GF4 star, this is 1 alpha, alpha square, right? So this set is a multiplicative group. Multiplicative group, okay? So with respect to multiplication, you can see that we can form the table. I think you might remember the table that we made actually earlier, right? So this is a multiplicative group. Okay. Okay. So now the next property that I would like to mention is that, again, this is kind of a theorem here, that every element beta of FQ is a field with Q number of elements, right, satisfies the equation beta raised to power Q is equal to beta, or beta raised to power P raised to power M is equal to beta. ओके, एवरी एलिमेंट, इस फील्ड कोई भी फील्ड ले लें, उसका कोई भी एलिमेंट, जैसे यहाँ पे हमने जीरो जीरो है, वन है, अल्फा स्क्वायर, दे सेटिस्फाई दिस इक्वेशन. Why is that? I think you can prove it by saying that suppose beta is some power of alpha, say alpha is for I, you compute this thing, and then while doing some manipulations, you will be able to show that beta raised to power q is equal to beta, or beta raised to power p raised to power m is equal to beta, right? So basically, in other words, we say that beta is a root of the equation x raised to power p raised to power m is equal to x. Okay. In other words, we can also write it like x raised to power p raised to power m minus x is equal to partial product x minus beta, now where beta belongs to fq. So this polynomial can be written like this product, right? Okay, another question. So I think, I just want you to verify this fact. Okay. Any question at this point? Because this is something that you can verify easily. And as I told you how you will verify, you assume that beta is a power of alpha. Okay. Say alpha raised to power I. And then do all the calculations to show that beta raised to power, Q is equal to beta. Okay. So because I think this also means that beta raised to power q minus 1 is equal to 1, right? And I think you have observed this fact earlier, right? that this happened. This was true for alpha actually, right? Alpha raised to power this thing was true. So you can compute this. Next, in GFQ, next property, there are exactly phi of q minus 1 primitive elements. Okay, so that means GF4 में कितने primitive elements होंगे? Q is equal to 4 हो गया. So number of primitive elements will be phi of 4 minus 1, which is 3. 4 minus 1 is 3, which is phi of 3. 3 is a prime number, so it is 2. So there are only two primitive elements. कौन से primitive element होंगे? Alpha and alpha square. These are the primitive elements here. Got it? In GF4, there are two primitive elements, alpha and alpha square. Okay? And I think you know that, I already mentioned this, but I'll just reinforce it. A primitive element alpha is an element of order q minus 1. That is, alpha raised to power q minus 1 is equal to 1. This implies that 1 alpha square alpha raised to power q minus 2 must be non-zero elements of FQ. Okay. Next property, a finite field exists for all prime powers. That means there is a field with q number of elements if and only if q is prime power. This is something I think you saw by example, but I hope this is clear to you. Another very interesting fact, if alpha is a primitive element, this implies that alpha inverse is also primitive element in a field. So now I think we can check, say in ZF4, alpha is primitive element, we know that. So alpha inverse is what? Alpha inverse is what? Alpha cube into alpha inverse, because alpha cube is equal to 1 is nothing but alpha square. So alpha square is primitive element, right? Because in GF4 there are two primitive elements, alpha and alpha square. This is how you can see that. Next property, if Px is a primitive polynomial, so is P star x, it is known as reciprocal polynomial. It is x raised power m times P of x inverse. It's known as reciprocal polynomial, is also primitive. So this is primitive polynomial. Okay. So I think we know that x square plus x plus 1 is primitive polynomial in GF4 actually, right? So we can compute what is this value. Okay. What is this? Another result, number of primitive polynomials of degree m is phi of q minus 1 divided by m. Okay. So these many primitive polynomials are there. Okay. So that's all about. Any question at this point before we proceed further?
No, sir.
So you are understanding everything here now?
हाँ जी सर, अब तक समझ
ठीक है, good. So I think you understood about primitive elements, primitive polynomials, right? And you know how many primitive polynomials are there, how many primitive elements are there. I mean, all those things you can know. Now you can know in the finite field. Now I am going to talk about another interesting concept known as minimal polynomials. Minimal polynomials. We call it as MP, minimal polynomial. Okay. So what is a minimal polynomial? So any beta which is non-zero element in FQ field with Q number of elements, we know that beta raised to power Q minus beta is equal to 0, right? We just saw that. So beta is a root of, so beta is a root of x raised to power Q minus x is equal to 0. ठीक है ना? Now it may happen that beta is a root of a polynomial of lower degree. ये जो polynomial है इससे lower degree polynomial को satisfy करे. Okay, so that polynomial is known as minimal polynomial. So we can formally define the minimal polynomial MP over GFP of beta is the lowest degree monic polynomial. Monic means the leading coefficient is 1, mx, for which beta is a root. So m beta is equal to 0. Okay. So if beta satisfies a polynomial of degree lower than this, so then that is known as minimal polynomial. So I think I can mention few facts without proofs, but later on I will show you few things here. In GF16, actually, if you write down the elements and minimal polynomials, I can make a table here. 0, minimal polynomial is x. 1, minimal polynomial is x plus 1. Alpha, minimal polynomial is x raised to power 4 plus x plus 1. Alpha square, minimal polynomial is x raised to power 4 plus x cube plus 1. Alpha cube, minimal polynomial is x raised to power 4 plus x cube plus x square plus x plus 1. And alpha raised to power 5, polynomial is x square plus x plus 1. So how do we get these things? I will show you after some time. So basically, but this is an example that, you know, when the elements are like this, we can list down their minimal polynomials. So remember, there is a little bit difference between minimal polynomial and primitive polynomial. Okay, and it will be clear to you after some time. Okay, so now I would like to tell you few properties of minimal polynomial. Okay, few properties of minimal polynomial. The first one, I will call it M1, the first property, that Mx is irreducible polynomial. That means it cannot be written as product of two lower degree polynomials. Can you tell me why? Any idea? Any idea why it cannot be written as product of two polynomials?
बिकॉज कोई पावर बीच में मिस हो जाए इसलिए
Uh, एक्चुअली बहुत सिंपल है ये. लुक एट दिस. Suppose mx can be written as product of two polynomials m1x and m2x. Okay, तो with m1x and m2x की डिग्री जो है ना लेस देन m है. ठीक है, तो डिग्री ऑफ mi इज लेस देन डिग्री ऑफ m. सपोज ऐसा है. ठीक है ना. देन क्या होगा? वी कैन सब्स्टिट्यूट x इज इक्वल टू बीटा ऑन बोथ साइड्स. So we will get m beta, right, is equal to m1 of beta times m2 of beta, right? M beta is 0 because mx is a polynomial with beta is a root. That's the definition, right? M beta is equal to 0. So that means this portion is 0. This implies that either m1 beta is 0, m1 beta is 0, or m2 beta is 0. In either case, beta is a root of a polynomial of degree lower than mx, which is a contradiction because mx is a polynomial for which beta is a root which is of lowest degree, right? So this is a contradiction, right? So that means ये assumption गलत है हमारा. ठीक है, इसका मतलब mx irreducible polynomial है. Got it?
Yes, sir. Yes, sir.
Second property हम mention करना चाहेंगे, which is also very interesting and very important one actually, that if fx is a polynomial, suppose कोई एक polynomial है fx, okay, जिसके कोफिशिएंट GFP में है, मतलब ग्राउंड फील्ड में है. ठीक है, okay, such that beta is a root of this polynomial. So I can say that, 1 minute, such that f of beta is equal to 0. Okay, then our result says that mx should divide fx. So mx is a polynomial of lowest degree. It's a minimal polynomial of beta for which beta is a root. Then if beta satisfies some other polynomial fx, ठीक है, then mx minimal polynomial of beta will divide fx. इसका प्रूफ भी बहुत सिंपल है, छोटा सा है. So let us see this. So what we can do, we can say that by division algorithm, we know that we can divide two polynomials, right? Fx can be written as mx into qx plus rx. क्वोशिएंट पॉलिनोमियल प्लस रिमाइंडर पॉलिनोमियल हम ऐसे लिख सकते हैं, राइट? mx से डिवाइड, सपोज करो ये पूरा पूरा डिवाइड नहीं करता है, कुछ रिमाइंडर पॉलिनोमियल बचता है, राइट? सपोज करो पूरा डिवाइड नहीं करता है, कुछ रिमाइंडर पॉलिनोमियल बचता है. अगेन आई पुट x इक्वल टू बीटा ऑन बोथ साइड्स. So 0 will be f of beta because beta is the root of fx is equal to m of beta times q of beta plus r of beta, right? And यहाँ पे क्या है कि degree of r should be less than degree of m by division algorithm, right? तो डिवाइड करेंगे तो रिमाइंडर की डिग्री हमेशा इससे कम आएगी जिससे हम डिवाइड कर रहे हैं, राइट? नाउ दिस मींस दिस पोर्शन इज आल्सो 0. दिस इंप्लाइज दैट r of beta is equal to 0. So इसका मतलब क्या हो गया? बीटा इज नाउ ए रूट ऑफ ए पॉलिनोमियल r जिसकी डिग्री m से कम है, राइट? अगेन दिस इज ए कॉन्ट्रडिक्शन क्योंकि m तो लोएस्ट डिग्री पॉलिनोमियल था, बीटा जिसका रूट था. सो दिस इज नॉट पॉसिबल, राइट? सो हमारा एज्यूमशन कि ये रिमाइंडर बचेगा सही नहीं है. दैट मींस fx is nothing but mx into qx. In other words, mx divides fx. Okay, and we are done, right? Got it? So इसका मतलब है mx हमारा मिनिमल पॉलिनोमियल था जिसका बीटा रूट था. अगर कोई पॉलिनोमियल fx है जिसका बीटा रूट है तो mx उस fx को डिवाइड करेगा. बहुत ही इंपॉर्टेंट रिजल्ट है ये, एंड दिस इज यूज्ड क्वाइट अ लॉट. Next, actually, property third that I would like to mention is that mx divides x raised to power p raised to power m minus x, or I would say that mx divides x raised to power q minus x. बताओगे क्यों होगा ऐसा? Yes, Komal, can you tell me? Can you hear me? बताओ कैसे क्यों होगा ऐसा? mx will divide this polynomial. अजीत, आशीष, कोमल, कोई बताएगा? आवाज आ रही है?
हाँ सर, आ रही है.
तो बताओ ना, ये तो बहुत सिंपल ऑब्जर्वेशन है. ध्यान दो कि
हाँ बोलिए सर.
mx is a minimal polynomial of beta, means mx is a polynomial of lowest degree beta जिसका रूट है. तो अभी हमने जो बोला है यहाँ पे, अगर कोई polynomial ऐसा है fx जिसका बीटा रूट है तो mx बीटा x को mx fx को डिवाइड करेगा, राइट? तो वी नो दैट कि बीटा इज ऑलरेडी a रूट ऑफ x रेज पर क्यूब माइनस x. उसका रूट है ना बीटा, ये देखो ना यहाँ पे, बीटा इज रूट ऑफ दिस x raised to q minus x, right?
Yes.
So this I can take it as a fx, right?
सर कोमल आ गया ऑनलाइन.
हाँ कोमल, हाँ बताओ. So you understand why this result is true?
Yes, sir, because beta is a root of this polynomial, and
Yes.
That m of
M of x, yes.
m of x will divide that px, that beta.
Yeah, using m2 and the property that beta is a root of x raised to q minus x, right?
Yes, sir.
Yes. Good. So I think yes, that's all. अभी इतना ही आज बताते हैं. नेक्स्ट टाइम मैं इसकी कुछ और इंपॉर्टेंट प्रॉपर्टीज करूंगा और मैं आपको दिखाऊंगा कि हाउ टू फैक्टर x raised to -1. इट्स अ वेरी ब्यूटीफुल एल्गोरिथम. एंड एक चीज ध्यान देने वाली बात है, जब भी हम ये सारी कैलकुलेशंस कर रहे हैं तो तुम लोगों को थोड़ा सा ध्यान देना है कि कॉम्प्लेक्सिटी वाइज क्या हो रहा है बेसिकली. ठीक है ना? ये थोड़ा कॉन्सेप्ट बिल्डअप करना पड़ेगा फाइनाइट फील्ड्स का. बट नाउ यू हैव टू थिंक अबाउट इट इन टर्म्स ऑफ कॉम्प्लेक्सिटी, व्हाट इज हैपनिंग, यू नो, व्हाट इज द कॉम्प्लेक्सिटी कॉस्ट इन ईच केस. ओके, सो फाइन, दैट्स ऑल फॉर टुडे. नेक्स्ट थोड़ा सा इन्वॉल्व है रिजल्ट, तो हम उसको थोड़ा सा जो है ना अगली बार में बताएंगे, नहीं तो कंफ्यूजन होगा. ठीक है? So thanks a lot. If you have any questions, you can ask me. So I hope you understood the basic. Okay.
Yes, sir. Sir, actually, sir, last week I missed classes because I was not well. So,
Uh-huh.
is there any recording or notes available so that I
हाँ,
can?
तो I think recording must be there. मैं भेज दूंगा recording. ठीक है? ठीक है? I will send it to you. No problem.
Yes,
Okay.
thank you.
Okay. So fine. Okay. Thank you. So see you in the next class.
थैंक यू सर.